The first step in the Meteor game is to create a room with a black background. Right-clicking on the room, you'll set the background color to black and press OK. Press the check mark to save the room, and we'll now create two different sprites. SPR prefix, UFO, and we'll load the sprite from the sprites space folder. Space, and you'll see our simple UFO over here. Press OK, and we will then add a large meteor sprite. SPR underscore meteor and LG for large, as we will have multiple size meteors, and we will find the sprite for that. Meteor large number 1. Press OK. OK once again to create our 2 sprite. Now, instead of having a stationary meteor, we will open it up and create a meteor that spins around in a 360-degree circle. Let's go in our Edit Sprite, and up by our animation, we're going to start the rotating sequence clockwise, which will spin the meteor around to the right. The number of frames is 5, and we'll keep the degrees at 360. When we press OK, we'll see that the meteor is now repeated 5 times. Each time rotates slightly, so that when we press our preview button, you can see it spins around in that type of fast motion. Now, the meteor is spinning a bit too fast right now, so we're going to slow the speed down. And we'll type in here 6. You can see how this meteor slows down considerably. Now we will press OK, saving the changes for this meteor. Let's now create similar sprites for a small and a medium meteor. SPR underscore meteor medium. Load the sprite. Medium. OK. Once we have the sprite assigned an image, we'll again edit it and set the animation sequence to rotate, this time counterclockwise, for a total of 8 frames and at a speed of 7. Press OK to save it, and one more sprite. Load the image, edit to create an animation sequence rotating, this time clockwise, 10 frames, and we'll do a speed of 9, slightly higher. Press OK to save it, and now you're going to want to go ahead and save your work. In addition to using sprites that have a predefined image, we can also create our own sprites in the sprite editor. Let's go ahead and create a sprite, name it SPR underscore, and we're going to name this Photon. And now we will go to our Edit Sprite menu to begin to create our custom photon. We will create our new sprite, and we will make sure that the canvas size is set at 32, and press OK. Let's double click on the image to open up the image editor. Over in the right hand column, we're going to select a yellow swatch in the left hand column. We will grab our ellipse tool, but first let's zoom in a little bit. You can zoom in by pressing Control and your scroll button. That will make your mouse just a little bit larger, or the canvas size. Let's grab our ellipse tool, and when I click on it, you'll see a couple other options come up from the bottom. There are 3 buttons in this area that determine how the color will be applied. The top button creates a shape that contains an outline but no fill. The middle button creates a shape with an outline and a fill, and the bottom button creates a shape that has a fill with no outline. Choose the top button. In the size area, now click the middle dot in the top row. This is the size of the outline in the shape. Draw a circle in the middle of the canvas and hold the control key. Move your ellipse to the center, hold the control key, and you'll notice that you pull a nice ellipse out, and you want to fit it into the size of the canvas that you have open, letting go when you are done. Now, left click on the red color swatch to set the color palette. Click the fill area button, which is the little paint bucket over here, and then click inside the circle to make the center red. Close the image editor, saving the changes that you have made, the green check mark. And now you have the basic image for the photo sprite. The photon will be the object launched at the meteors to destroy them. To make the photon more interesting, we'll also animate it to start out at full side and then shrink until it disappears to simulate as it loses power. In the sprite editor, we are going to click animations to create this feature, and we will go down to where it says shrink center from the pull down menu to shrink the center of the photon. As you can see, a number of frames similar to you saw before comes up, and we want to enter 20 in the box for the number of frames. Pressing OK to create all 20 frames, and you can see how over the course of the 20 frames the photon will get smaller and smaller and smaller until it disappears and then resets. Let's change the speed to 10, making sure the show preview box is selected so you can see what's happening. Then let's press OK to save the changes, save your sprite, and then save your file again. With the first round of sprites completed, we will now create the objects that will allow us to place the sprites into each room. Remember your prefix is OBJ underscore. I'll do UFO first. I will assign the UFO sprite to the object. Visible is checked, solid is not checked. Press OK, and repeat the same process for all of the sprites that you have already created, making sure you keep your prefix the same. OBJ, Meteor, large, visible, and solid, and work your way down the list. And the last one for our photons. Oops, adding sprite properties here. Just delete that. And our object not creating another sprite. Gotta be careful. Okay, once all your objects are created, once again save your files so that you don't have to go through that process again. With our sprites completed, we will begin to create the player, or an avatar. An avatar is a representation of the player in the game. The UFO will represent the player and will launch photons to the falling meteors. To do so, let's open up our room properties and expand your window so you can see the entire thing. With the room open, we are going to make sure we place an object, which is the UFO, towards the bottom of the page, somewhere in the middle. Approximately there is fine. We're also going to put in 2 instances of meteors, the large ones, and make them towards the top of the screen, and make sure they're not overlapping. With the room set up, we will press the check button to save the room, and now we will start to program so that when the player presses the space bar, a photon will be launched from the UFO object in an upward direction. Let's open up the object properties window, and the first thing we need to do is to add an event. The event we want to add is a key press, not keyboard, because we want to just press the button once and let go. We're going to add a key press, and that is going to be the space bar. So now when we press the space bar, an action will happen. The action we want to happen is from the main file for an object to be created. What this is telling the program now is when you press the space bar, the UFO will create an object. Or rather, excuse me, when the spacebar is pressed, it will create an instance of itself. That's what the radio button over here does. If it was other or object, we could specify something else to create. When the spacebar is pressed, we want to create an instance of the UFO. And now, down here in the object box, we want to select a photon. This command is telling the program now when the spacebar is created, it wants to create an instance of itself and of the object. Make sure in the text boxes in the window you have X and Y at 0, and we want to check the relative checkbox. Remember, relative means from where it was before. This will program the photon to appear at 0 pixels to the right and 0 pixels down from where the UFO was before. In other words, the photon will appear in the exact location of the UFO, making it look like it is originating from the UFO. We will press OK to finish creating the instance of that object. We can now close the object properties for the UFO, saving the changes, and now open up the object properties for the photon. The first thing we want to do is we are going to add event, and we are going to add a create event. The create event will create a photon, and now we are going to move over to our move and drag the speed vertical button from the move tab and drop into the actions column. In the dialog box that appears, click the self radio button, which is now setting the speed for the photon vertically as it will be traveling up. Now, in the vertical speed text box, enter -8. A negative value will move the object upwards. Remember, in Gamemaker, the positive and negative y directions are reversed from the normal coordinate system you may have learned in math class. So instead of negative being down, negative is actually up. So when the photon is created, it will be moved up for -8. Let's go ahead and press OK. OK again, and save your work. Now in Gamemaker, objects that are created can exist even if the player cannot see them. You likely have played many games that allowed you to walk around and see things that do not exist outside of the current scope or the visible playing area of the game. This can help make the game great, but it can also slow down the gameplay as the computer must keep track of all these different objects. One way to help solve this problem is to destroy any objects when they are not in the visible playing area. In the Meteors game, you will create the programming to destroy any instance or any copy of the photon object when it leaves the visible area of the room. Otherwise, the computer will track the instance as it travels upwards forever and slow your computer down. Let's open up the object properties for the photon once again. In the event button, we want to add an event, and we want to now add a other event, which gives us a submenu followed by an outside room. So if the outside condition is met, we want to have an action that destroys whatever instance is outside the room. So we can go and find our objects destroy, move it over, and make sure the self radio button is applied. Now, if the object is created, it is outside of the room anywhere, it will destroy itself. Press OK. Let's now close out our dialog box, making sure we save the changes. And let's give our first test run of the game. Test player game to launch the photon by pressing the spacebar. Notice that the photon is generated at a weird place. It's not in the center of the UFO, it's off to the side. These problems will be fixed, and we will do so in the next section. First, notice the speed of the spinning meteors. If the meteors are spinning too fast, you will need to change the room speed or animated frames. We already changed the animated frame, so we'll probably have to slow down the room speed. Let's cancel out of the game. Open up our room property. And in the speed tab, let's set the speed tab down to 10 instead of 30, which will slow our meteors down considerably. If you'd like to see if they slow down, you can. Now we're going to open up the sprite properties for the photon. You noticed before that the sprite was fired from the left of the UFO. This is because the program automatically sets the red circle, or the photon in this case, to the top left corner. We can fix this by pressing the center button, and notice that the crosshairs are now dead center in the middle of our photon. If we press OK and save this, we'll notice when we run our game again that the meteor should, number one, be slowed down, and the sprite itself should still be firing. Okay, it's off to the left, so we have to go back and check to see what's going on. Let's open up our UFO sprite and check to see if we're not centered, which we are not. So let's click centered here, and now we should be dead center. Execute the game again, and our photon should fire directly out of the center of our UFO. And there you go. And you can see the pulsing and the speed of the meteors that is spinning around. X out and save your. When you saw the game running, you noticed the photon was pulsing a little bit too fast. We want to program the photon object with this logic statement. If the animation ends, then we want to destroy the instance. The animation end event is located in the menu displayed by clicking the other button and choosing add events to the dialog box. What this will do is when the photon is done going through its 20 frames, it will destroy itself. We have to edit the object properties, and now in the add event we want to select other and animation end. So now as the photon is created, if it's outside the room, it'll be destroyed. If the animation ends, we also want the object to be destroyed. We will go to our menu and drag the box in, and we want to make sure that it destroys itself. Press OK. Next, we want to edit the vertical speed action of the create event and change the speed to -20. To do this, double click on it, and the time speed of the animation, so the photon speeds, so the photon fades as it comes out of the box. We will set the vertical speed to -20, and now there are also 20 frames to the photon, so once it goes through all 20 of its frames, it will have reached the top of the screen and will be deleted. Press OK, and let's test to make sure that those changes have taken place. As you can see, the pulse is slowed down, and by the time it gets to the top of the screen, the photon is gone. Now we have to move our UFO around so that we can get underneath the meteors to blow them out of the sky with our photons. Let's open up the object properties box of the UFO, and we're going to program this logic statement. If the player presses the right arrow key, then the horizontal speed is 15. Make sure you do not use relative, or every time you press the space bar, the speed would increase from 15 to 30 to 45, and it would be way too fast. So we will add an event, of a key press of our left arrow. And when the left arrow is clicked, we want to set our horizontal speed. We want to make sure that the action applies to itself. And so if the left speed is pressed, we are going to apply a speed of -15 to get it to move in the proper direction. We'll do the same thing, add an event for the right press with a horizontal speed of 15, making sure it's not relative, and press OK. In order so that the meteor or the UFO does not fly off the screen, we will create an event that allows the UFO to go out one side and wrap back around to the other side. We're going to add an event, again clicking the other button, and then we'll select outside of room. And now we are going to tell the UFO that if it moves outside of the room, we want to have it wrap, which is under the move tool, move tab here. This will send the UFO, as it goes to the left, back across to the right side of the screen. Press OK, and test, save and test your game. If your game is working correctly, we can now program the exploding meteors. Now the player can move around. However, all that can be done is launched photos. We saw that when launching photons, they go right through the meteors. The photons are supposed to explode the meteors, but they will not currently because they go right through them. Remember, right now, just because an object looks like it's something in the real world does not mean it acts that way. We need to program it how the object acts. So what we need to do is add a new sprite named Explode. And that is located in the Maze platform game. And you have Explosion Strip 7. And you notice that this is already animated. We'll press OK. And we will make sure we move the center origin to the center of the meteor at 16 by 16. And we can press OK. Now let's create a new object for our new explosion. And assign the proper sprite. Now we want the explosion to disappear once it cycles through its animated process. We'll use the same steps we did before and add another event, which is animation end. If the animation ends, we want it to be destroyed and the instance applied to itself so that it is gone. Press OK, and save your work. We will now work on setting the collisions when the photon hits the meteors. Let's open up our photon, and we want to add an event of a collision. The collision we want to create is with the large meteor. So now our statement is saying is when the photon collides with the large meteor, what action will take place? The action we wish to create is going to be the creation of another object. The object that's created applies to an object. And in this sense, we want to make it a large meteor. So when the large meteor is collided with the photon, the object of an explosion will appear. So now the photon meeting the meteor will keep the meteor there because it will create an instance of the meteor and it will create an explosion. Make sure you have the relevant check marks checked here, as this will create the explosion in the exact location of the large meteor. Press OK, OK again, and test your game. As we move around the game and we fire our meteors, they should hit the meteor and explode. Now you'll notice they're not exploding directly on top of the meteor. It's because we do not have the meteor centered in the sprite menu, which we'll fix momentarily. Let's go back into the UFO large meteor, center each of the sprites, and retest our game. Now as we fire our photons at the meteors, they should explode directly on it. Now the one problem you may notice is that exploding on both meteors and not just one, which we'll fix in a moment. X out. Now many times when you're creating games, you want a series of actions to take place when a single event condition is met. This can be done by using blocks of code instead of just one file. In this game, the photon and the meteor should both be destroyed at the same time when the explosion appears. Let's start doing this by modifying the object properties for the photon. If we open the dialog box, we can select the existing collision event with the meteor to show the actions that are already programmed, which is here, which creates the explosion on the meteor itself. Go over to your control tab and let's pull in our start block. Drag it and drop it above the existing action so that it appears on top, or pull the other one underneath it. Below the created action, let's add a destroy instance action to the photon. So we will go get our garbage can and we will destroy instance of the photon. By selecting the destroy object of the photon, when the collision hits the meteor, the photon will disappear instead of continuing on its path. We'll press OK to save this. And now we want to add another destroy instance, and in this case we want to destroy the large meteor. Because the photon has hit the meteor, it will destroy both the meteor and the photon, leaving just the explosion to run through once. Once we have our two actions programmed, press OK, and back on the control tab, we will drag the end block of this section of codes. We'll press OK and test save your game to make sure that the meteor, and we'll move right and left, and our UFO should get lined up, release the meteors, and when it hits, it will destroy the entire meteor. As you saw, the explosion, perfect. Now that we have some basic gameplay programmed, we will start to address some of the flaws that are in the game. Most notably, the fact that all the meteors are destroyed whenever one is hit with a photon. This type of error is very common with game programming, and it was built into this lesson so you can learn how to fix it if you experience when designing your own games. The fix is easy. Let's open the object properties box for the photon, if it is not already open. Select the existing collision event to show the existing actions for that event. Here's your collision event, here are your actions. This contains the block of code you created in the last section. One of the existing actions of this block needs to be edited. Hover the cursor over each of the destroy instances actions to identify the one that destroys the large meteor. In this case, it is the first one for me. The second one. Double click to open the destroy action dialog box. In the radio aspect window, click the other button. This means that when the photon collides with the large meteor, it will destroy the object the photon collided with, or the other object. In this case, the meteor on either side, and just that meteor. The meteor on the other side will not explode. However, before it will work properly, we must also go to the create instance, and in this sense we must create the explosion so that it only happens to one. So in this instance, this created the explosion, but instead of the explosion happening when it intersects with an object, we want it to only explode the other object that's coming in contact with it, which is just a single meteor. Let's press that, and once again, test our game. Let's bring our UFO around and hopefully we'll be able to destroy each meteor individually. And there you go. Now that the meteors are working properly, we are going to have to program the rest of the meteors to react the same way when they interact with the photon. To do that, let's open up our photon menu. But now, instead of writing all this program all over again, we're going to open up the event that causes the proton to destroy the meteor and cause the explosion. Let's hold the shift key and just select all of the code blocks. We'll then copy it to the clipboard so we do not have to create it again. Now we'll add an event that when the photon collides with the meteor, we can simply paste our code and it will be the exact same code. And because we are creating the instances that destroys the other object, we don't have to change any of the parameters. Let's add an event collision for the small meteor, paste again, and press OK. This will create that same explosion process for all three size meteors. Let's now test this feature. In our room, we will add a couple of the medium and small meteors, making sure they don't overlap. Oops, small. If done correctly, when the meteors are pressed, they will all destroy themselves. So once again, let's execute our code. And medium explosion, and there you go. Each of the size meteors are exploding when they are pressed with the photon. Alright, if your game is working up to this point, so far so good, come back and let's save your work. With the program correct for the photon intersecting with each meteor, we now need to add scoring and make the meteors move. Before making the meteors move to make it more difficult, you will program and test the scoring. Testing the scoring will be easier if the meteors are not moving, as you could destroy them a lot quicker. Let's open up the Object Properties box for the photon. And in here we will select the collision event for the large meteor. We already have our programmed action that happens when the proton intersects the meteor. And now we want to, below the block of code, add a set score action to increase the score by 5 points relative to the previous score. Remember back to the click ball game how we did this. Let's go, and we'll take our score tab and we'll set our score at 5. Now remember, in this sense we want to press relative. If we do not press relative, every time we hit a meteor the score will stay 5. If we press relative, 5 points will be added on for every meteor that we successfully destroy, and press OK. Let's also go ahead and edit the collision actions for the medium meteor with a score of 10 relative, and the small meteor as 20, and this is the hardest one to press. Press OK, OK. Play your game and make sure your scoring is working properly. If your scoring system works properly, we are now ready to add a life object to the game. This will limit the player to a set number of lives to make the game more challenging and interesting. Let's open up the Object Properties box for the UFO. We will add an event to the UFO and have a create instance. To create instance selected, drag the score caption from the score tab, which looks like this, into the actions button. If you click in the show lives, you can select to show the lives that are left over for each player. This will display them in the top title bar of the game window, just like the score. You can see how the score is set to show score and score captions that will appear. Drag, press OK, and now let's set the lives tab into the dialog box, and we'll give ourselves 3 lives. Do not check the relative box in this instance, and press OK. This will allow the player to start with 3 lives. Now we need to add the programming to remove a life when the UFO collides with a meteor. Start by programming this logic statement, that if the UFO collides with a large meteor, then subtract 1 of the total lives. We will add a collision event with the large meteor, and the action that will take place is we will set our lives to -1. So as the meteor intersects with the UFO, we will lose 1 life, and so you can see that changes. Let's press the OK so that the action is saved. Now, with our collision event, we have our lives destroying, our lives being -1. We also now have to destroy the instance from the main tab 1 and drop into the actions column. Destroy instance box, let's click the other radio button, and the other instance is the UFO, to be destroyed when the UFO clicks. Let's click OK, and we will save the action of destroying the UFO when the meteor intersects it. Let's create similar programming for the medium and small meteors. We can say collision with a medium meteor, with a medium meteor, and that is going to subtract 1 life from us. And it will destroy the instance of the other object. Now, if you were paying attention, this is the same code as we used for the other 2, so we can actually hold Shift to select both of these, copy them, create another collision event with the smaller meteor, and paste them into place. Let's press OK, and now check to make sure that each of our meteors destroy the UFO and create our lives. So what we're going to do is we're going to go into our room, and we are going to place the meteor in the path of the spaceship. 1 here, and a medium one over here. When we save this and run our game, we'll be able to purposely run into the meteor and make sure that it disappears and we set our lives. With our game now running, we should be able to move the UFO back and forth, and our lives should be set to -1 every time we connect with the meteor. So we go to -2, -1, and then to 0. If we move left or right, you'll notice that our score is instantly set to 0. We will have to fix this. Let's see why this happened. Can you figure it out? If we open up our UFO programming, the collision with our meteor sets our lives to -1. With the lives set to -1 and the relative box not checked, whenever the meteor impacts the UFO, the score literally gets set to -1. Instead of setting it to -1, we want to subtract 1 relative to the score that's already there. We'll press relative, OK, and change for the other instances to be relative. Now let's go back and check to see that our score of lives moves down 1 at a time instead of being set to -1. Alright, now we have fixed that bug. Next, we will need to program what happens when the number of lives a player reaches is 0. Here, you will program to end the game and display a high score table. Let's open up the object properties for the UFO box. And add a collision event, or select a collision event with the large meteor. We want to set a block of code to be executed, so we will bring in our start block and our test lives command. This command will constantly test and look to see if the number of lives is a certain number. In this case, 0. We now want to enter an action of ending the game when the lives is 0. We will end the game. Oh, I'm sorry, let's destroy the instance. Let's end the game. Now let's go to our high scoring tab and drag the show high score into the box to represent the players' names of the score. In the show high score dialog box, you can edit the font, background, and colors for the high score table if desired. After you're done adjusting these values, click OK to save the action. Now we need to drag the show high score table action above the end of the game. This is necessary or the game will end before the high score table is displayed. Remember, the blocks of code start from the top and work their way bottom. Let's take the end block, drop it to the end, and there's a block of code that will test to see if the lives are equal to 0. If they are, it will show the high score table and it will end our game. Before we are ready to execute the game, we must take what we call a qualifier, or the condition that must be met before the code block will execute. In this case, the qualifier is if lives are equal to 0. We want to move this above the block, otherwise it will not work properly. Moving if lives are equal to 0 above, you'll notice that now in our block we only have our 2 commands to execute. Let's go back and change the same value for the small meteor and the large meteor. Press OK to save these changes, and now let's play to see if our game runs properly. As we move, we subtract a life, second life, and a third life, and our top player score pops up, and press escape to close. Now our game is pretty basic. It's very easy to shoot at meteors that are not moving whatsoever. Let's go back to our room and replace our meteors so that they're a little bit higher up at a different starting distance. Remember to move any of these objects, select the object, and hold Control, and you can move it. Now we don't want them to hit each other. What we'll do now is we will create programming that allows the meteors to move in a specific direction, left, right, and down, so that it's more difficult to shoot each one. To begin moving the meteors up and down the screen as a bigger challenge, let's first open up the meteor event once you have made sure that your meteors are moved up and out of the way of the UFO. If we open up the large meteor event, what we want to do is we want to add a creation event. So when the large meteor is created at the beginning of the room, we're going to give it a motion path. The radio button means that we want to apply the motion to itself, and down, left, right, down are the 3 potential directions which we want it to move. We will set the large meteor to a speed of 10, and we'll keep the relative box unchecked. Let's save this and do this for the remaining 2 meteors. Each meteor, we will change the speed slightly, making it more difficult to play as the meteor will be moving faster. Okay, check and save the game. The 3 meteors now should be moving at a different speed as they come careening down to the top of the screen. Okay, everyone's moving but the small. Let's go back. It looks like we may have forgotten to program the small to move. So Let's take a look at that. And we forgot to set the distance going down. Double check. And that should fix those particular instances of the problem. So each meter moving down, and we're good to go. However, the one problem is that you'll notice that once they move off the screen, they are gone forever, which is obviously not an ideal situation. Let's close our emulator and save our game to this point. As we were playing the game, the meteors should be continuously generated in a random fashion. While there are many ways to do this, we will use a very simple method so we can practice our skills. To start, we will need to create some launching points for the meteors. Doing this, we will need more objects that randomly launch meteors. The meteors. Before we can make these objects, we're going to create 3 new sprites, which I've already created, and they're going to be sprite apple, sprite banana, and sprite burger. Each of these sprites can be found in the maze platform folder. Go ahead and create these 3 objects, these 3 sprites, and when you are done, create each object for each sprite. But remember, the objects that you're creating should be visible and not solid. You now should have all 3 sprites created and the 3 new objects of apple, banana, and burger created, making sure each one is visible, however not solid. We're going to open up our room, and I'm going to move my meteors across the top of the path. So for now, let's get rid of the meteors that we already have here, which we can put back at a later time. And let's place each of the new sprites we've created in the room itself. We're going to create the apple in the top left corner. We are going to put the banana in the middle, top center. And we are going to put the burger in the top right. What we're now going to do is to move new objects across the top of the screen and program each collision to generate a meteor. By changing the speed and the path of each object, the collisions will occur at random intervals, making a great challenge for the game. To first do this, we must create a path. The path folder is over here in the resources tree. We will click and say create path. You'll notice the path dialog box is displayed. In the name box, let's type apple, which will enable us to create the path for the apple. Naming it how we normally is, as capital PATH underscore apple, letting us know that this is the path the apple will create. Click the origin point, which is in the top left corner. You'll notice the X, Y, and speed button will change as you create various spots. I'll Control Z back to the beginning, or undo, as we want our points to be deleted. Again, I will click in the top left hand corner until a 0, 0 point comes up here, and you'll see the coordinates displayed in the dialog box. Randomly click on the grid to create a regular path along the top of the grid. Each time you click a point or a node, a point along the path is created. To select the current node in red and other nodes that are in blue. This helps you to keep the nodes in order. Gamemaker creates a path script and displays it in the window below each node of the path. Changing the X and Y values will give you a different place for the node in each spot. I'll randomly change this to 250, 250, and you can see how it changes. The speed will not change the outline of the path, just the rate at which it moves around. We also have curved lines, which you can notice round off each of the points. And we have the close, which instead of returning back to the beginning, moves along to a point and does not wrap. So close will send you back to the beginning in a continuous loop wherever you choose to drag each one of the loops. Remembering that the curve button or straight line will get you a more direct path, as the shortest distance between 2 points will always be a straight line. The precision box over here determines how much pull each node has on the curved path. Enter 1 and you'll note the path segment becomes more straight line. We'll pull things together. A lower number will allow for a larger curve to come through. Now, hopefully we have a better understanding of the path that we have drawn, so we will clear this path and draw a correct path for this particular object. Now that we know a little more, let's clear the path, making sure we have a clean slate to work with. First thing we're going to want to do is locate the first node at point 0, 0, which if you'll notice down here, the X and Y shift as you move. So when we get to point 0, 0, let's click to start the first point, which now appears over here in the node window. To add the next node, we're going to select the Add button. Notice the point is at 0, 0. Let's change the node for the X-axis to 640 and the Y-axis to 32. You'll notice the line shoots across the top of our grid, giving us the coordinates here of 620 by 32. Now that the node is inserted, let's click on the node to select it. Once it's selected, we can change the speed of it by entering 20 in the text box. You'll notice up here again, now that we have the coordinate and the speed at which this node will be traveling. Oops, let's go back. We wanted to change the speed of the first node instead of at 100 to 20. So we'll click on the first node. You'll notice the speed changes to 20. And on the second one, let's click here. And this one will change the speed to 40. Oops, making sure we delete the 21st and entering 40. Alright, let's now add a third node with a X coordinate of 400. This is a Y coordinate of 0 and a speed of 30. A fourth coordinate, X at 200, Y at 16, and a speed of 10. Make sure the object path is closed so you see that we always end up back towards the center of the starting point. Let's close the form by saving it. Okay, now that we have created the path, we need to apply the apple to move along that path. So we're going to open the apple's property box, and with it, the first thing we need to do is to create the instance of the apple. So now once the apple is created, we want to drag the set path button from the move tab, which looks like set path. Drag it from the move tag into options. So now we know when the apple is created, we are going to set the path. We want to apply the path to the apple itself, and we want to click the path button to follow the path for the apple that we have created. The speed we're going to create is going to be 30, and we're going to click at the end. Instead of stopping, we are going to continue from start, that it continues to loop. In the relative check box, let's check absolute from the menu. So now we have our radio button applying to itself. The path is the apple. The speed is 30. At the end, we're going to continue back to the start, and our speed is absolute, meaning that we'll continue at the same speed and not speed up or speed down. Click the opaque OK button to set the path, and let's test play the apple to see if we have successfully created our script. You'll notice the apple is now moving along our path. And is slightly bouncing outside of the room, but is always coming back and returning to our point, slowing down as it hit each node's the different value for the path applies. Okay, let's X out and save our work. With our apple path successfully making, we're going to now create the paths for the banana and the hamburger. We'll go over to our paths and create a new path, naming it capital PAF underscore banana. So we can now create the second path for the banana to follow. The first node we are going to create is going to be at 320 by 0, because the banana should start at the top center of the screen. Create a randomly jiggy path. All nodes should have coordinate of either 0 or 64 and an x coordinate of 0 and 640. The speed should be 100 for all the nodes. Let's add our next coordinate, and for our x-axis, which remember goes back and forth, we're going to move a little further to the right this time, and we'll go 380. And we want to set our y coordinate to either 0 or 64, so we'll create this one at 64 and a speed for 100. You'll notice our node comes back down over here. Our next will be 420, and let's create this at 0, and you'll see how we're moving up, down, and around. Let's create our next one at 448. And 64, which you can see we're now moving way far over. Oh, 448, not 40. There we go, it's more realistic. And our speed of 100. I'm going to add the next at 528 and 0. Then I'll do one at 576 and 64. 592 and 0. And you can play around with these values until you like the way your particular path is following around. I'm going to use these for now, and we'll see how it turns out. 624 by 64. 640 by 0. 528 by 64. 288 by 0. And 274 by 64. Now for these creation events, remember that all the nodes should have a y coordinate down here of either 0 or 64 and an x coordinate between 0 and 64 with a speed of 100. With a nice path, remember we could set it as a smooth curved line so it moves smoothly, or a straight line. And just make sure your path is close so that it repeats itself as we go through. We're going to save this, and now we're going to add the path to the banana object. Under our path, first make our creation event to create the banana, and then we'll move our path to itself. The path is going to be banana. Let's set our speed for this particular path at 40. At the end, we're going to want to repeat. Just continue from start, and let's set our speed to absolute. Save your events and run your game. You'll notice how much quicker the banana is running and how we only move from the center back and forth. Looks kind of funny with a banana bouncing and banana and apple bouncing, but this is what I'm looking for at this point. Let's see you create a path now for the apple. Start by creating a randomly jagged path up and down, all the way around. As you go, all nodes or all grid points should have a y-coordinate here of 0, between 0 and 96, and an x-coordinate between 0 and 640. Once you're done, set this to a smooth path, as it will notice you'll move it to the inside of the nodes that you create. Click on the first node in the path script and notice it turns green. This will help you keep track of the nodes. Drag the selected nodes up and to the right so the path is closer to the 60/40 node. Add the path to the object when you are finished and create a speed of 10. Just to start, we will create the first coordinate for the burger at 640 by 0, and we'll add. You'll notice you're over here. Now you can create your jagged path as you so wish. With my path now created, I'm going to come down and change my straight lines to smooth curves instead, and you'll see how the paths move inside of the object. You can also adjust these paths by moving and dragging the lines until you get the exact features and path that you want. Let's check and set the score, making sure our smooth is selected. We'll press OK. And now let's set the path for the object of the burger. So we'll create the burger. We will use the path of our burger. We'll use a speed of 10. Start over at the beginning. And a absolute or constant speed. Okay, save, save, save. And now we should have our burger, apple, and banana moving all over the screen. And there you can see the various paths of the burger, apple, and banana. You can see how the burger is sliding around more like a curvy shape, and these are more pointed. With our paths now set, we want to program our game so that the meteors will follow those paths and randomly create themselves into the gameplay. To do this, we must program the apple with an if-then statement that if the apple collides with a banana, then a large meteor is created at the apple's position. This will consist of a collision event with the banana, and if this collision event happens, we want to create, if the apple collides, the banana collides with itself, we want to create an instance of a medium object, or I'm sorry, a large meteor relative to the position. So the two intersecting points, that's what we created. We're also going to add a collision event, whereas a collision between an apple and the burger is going to create a medium meteor relative to where it is. And now for the banana, we want to set the banana, if it collides with the burger, create a small meteor relative to that position. Let's take a look, test the game, make sure it works properly. You can see as the apples, which you cannot see, are moving around, they are randomly colliding with and creating additional instances. Escape out. Now, if you still saw your apples and your bananas at the top of the screen when you tested your gameplay, you need to make sure they are not visible. So the objects are still in the room. The apples, bananas, and hamburgers will still move around their paths. However, you will not see them when they intersect and creating the meteors. Now, to make our game a little bit harder, you'll notice that when the meteors move through the screen, they disappear when they're outside the room. What we want to do is wrap the meteors in both directions when doing so. So if you open up your large meteor and you create an event for outside of the room, what you want to have happen is that the meteor will wrap itself both in horizontal and vertical directions. Copy this step for both the large, small, and medium meteors. Once this is finished, you are done with the next part of the video. If you have already hid the burgers, bananas, and apples at the top of the screen, we will make just a couple more tweaks to the game. First, let's add a title page with a new room for the game, your name as a game designer, title of the game, and some type of simple directions on how to play the game. Locate sounds that are appropriate for each of the actions, which is launching the photon and the exploding meteors. And finally, program the sound to play properly. Review the different activities that we've done in this lesson to make sure this works. Lastly, make sure you save your game, and this completes this particular step.